let's take a look at level 3.1, the Isosceles triangle theorem. And as we look just down below our title here, we see parts of an isosceles triangle. And the first bullet point here is that the two congruent sides are called legs. So side AB and side BC are legs. So let's write that down. This is a leg, and this is a leg. The angle where the sides intersect is called the vertex angle. So when we look here, angle B here, because this leg and this leg intersect at angle B, is the vertex angle. The side opposite, so I sometimes draw an arrow like this. I know I wrote it very light, I don't want to jumble up the picture, is called the base. And the angles along the base are called base angles. So angle 2 is a base angle, and angle 3 is a base angle. So let's take a look at the isosceles triangle theorem here. And the isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if we stick with this picture up above, what happens is we know that side AB is congruent to side CB because we've got a tick mark in both of these. And what that tells us then is if we take this tick mark and we kind of extend it over here to 3, do the same thing with this tick mark over here to angle 2, what we can say then is since those two sides are congruent, then we can also say that angle 2 is congruent to angle 3. And again, that is because those angles are opposite the congruent sides of our given triangle. If we look at the converse, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So it's the same idea here, only this time we're going to start with the angles. It says if two angles are congruent. So if we look at angle 2 and angle 3, and this is completely separate from what we were just doing, if angle 2 is congruent to angle 3, then we could draw our arrow the other direction, and we could point it here. Same thing here. With angle 2, we could draw this arrow the other direction. And what we can say then is we can say that AB, side AB, is congruent to side CB. Just one more time so you can hear me. If we have two congruent sides, then those sides opposite those congruent sides are congruent, and it works the other direction. If we have two congruent angles, like the base angles in our isosceles triangle, then the sides opposite those base angles are also congruent. And that's what the isosceles triangle theorem and the converse of the isosceles triangle theorem state.